I'm Brian Freer, tutoring high school physics. Today's topic, springs and forces. So springs are fun objects, and here we have a spring attached to an object. Now, for those of you who have played with springs before, you know that if you leave them alone, they'll naturally stay at some length, and then you can either compress them or stretch them out. Now, this natural kind of length is basically its resting length. If it's like this, it's not doing anything, and we're going to say that this is its resting length. However, if we compress it or if we stretch it, then a force is going to be created, known as the restoring force, and that's going to pull it back into its original kind of resting length. That's described by this equation, Hooke's Law. F equals negative kx, where k is the spring constant, differs from spring to spring, and x is the distance from your resting position. So this negative sign only serves to say that regardless of the direction you push or pull your particular spring in, it's always going to be pushing or pulling back in the opposite direction. So if I compress the spring, it's going to push right back this way. If I pull it out, it's going to push right back this way. Regardless of which direction I compress or expand the string, it's always going to go back to its resting position. Okay, so let's work through Hooke's Law. Let's say you've got our spring and we compress it 5 meters away from its resting position. So the force generated is equivalent to negative kx equals, we have a k of 5 newtons per meter times an x of 5 meters, and we get that we have generated a force of 25 newtons within the particular spring, and it's negative. I'm omitting that from the final answer. I'm just going to say that it's going to be a force this way, back to the center, back to its resting position. But let's say we expand it. Well, actually it's pretty much the same thing. We have the exact same k, 5 newtons per meter, times 5 meters, and that's going to be 25 newtons. Doesn't matter which way we send it, the force we're going to generate is still the same. The only difference is the direction in which it's going. This time it's going to be going in the opposite direction, but still towards the center to the resting position. Alright, to recap. Spring can be compressed or expanded, but will always return to their resting position. Compressing or expanding a spring will create a force as described by Hooke's Law, which states that force equals negative k, which is the spring constant given to you for each spring, times x, which is the distance from the resting position. The negative only serves to say that the force will be opposite to the direction in which the spring has been compressed or expanded. Alright, that's all for now. Again, I'm Brian Freer. See you next time.